The x and y coordinates of the particle at any time are given as x and y respectively, where x and y are meters and t is in seconds. The acceleration of the particle at 2 t is equal to 2 seconds is. Okay, so this is a really good question. This requires certain understanding of vectors, which is something that is not supposed to be discussed in chapter 1, which is motion in a straight line. But let me just give you a just small hint of this. See, vector A can be represented as AXI plus AYJ plus AZK, which means this vector A is basically the or this vector can be expressed as the sum of the components along the I, the J, and the K axis. Sorry, the X, the Y, and the Z axis. Now, what is AX, what is AY, what is AZ, and what all are these I's, J, K? I think that's no point in discussing this topic over here, because there's an elaborate set of questions which will be used to explain you the concepts. Well, what is I, what is J, what is K, what are the rectangular components, how do you resolve them? All these questions will be clear when you start doing problems based on motion on a plane. And there's exclusively done dedicated video which is based on vectors. So let us not go much into it, but as of now, just try to understand that modulus of vector A is equal to root of ax square plus ay square plus az square. This is all what we require for this problem. Okay, so what's given here? See, x is given as 5t minus 2t square and y is given as 10t. Now, see, the only thing that we need to do is to find the acceleration, right? Now, what is acceleration? Acceleration is rate of change of velocity, right? So, what is velocity is the rate of change of displacement, and what is acceleration? Rate of change of velocity. So, basically, all we need to do is differentiate this equation once, and what do we get? We get 5 minus 40. Differentiate it once again, what do we get? We get minus 4, right? So acceleration is equal to minus 4 is what you get. Is usually what students do. No, there is a mistake here. What is that? When you differentiate x with respect to t, what you get is vx, velocity in the x direction. When you represent Vx with respect to time, what do you get? You get Ax, which is basically acceleration in the x direction. Now I think you're able to understand what is this Ax. Now, we have solved so far only the x component. What also is given is y is equal to 10t. And what would that be? Vy is equal to 10 and ay would be equal to derivative of 10, which is equal to 0, right? Which further means that I can write vector A as minus 4 I cap plus 0. Okay, well, in this case, there is no need to write the three-dimensional component because only x and y are given. So I can just I and j plus 0 j. Okay, in which case, let us now bring in this formula. What is modulus of vector A? Modulus of vector A would be equal to root of minus 4 square plus 0 square, which is equal to root of 16, which is equal to plus 4. And since this is acceleration, we can say that acceleration is equal to 4 meter per second square.